Hello, welcome to Parkson's 101 training presentation for EcoCycle SBR. My name is Jeff Angman, and I'll be walking you through the EcoCycle process. The SBR process is an activated sludge process for treating wastewater, and when you compare it to conventional activated sludge, everything's done in the same tank in an SBR. So unlike a conventional process where you have primary clarifiers or secondary clarifiers and separate aeration basins, everything's done in the same tank, so it's just changing what's happening in that tank. Instead of going to a separate clarifier, you're just using the entire SBR tank it's settled out in. And same thing with the aeration basin. You're using the SBR during aeration time to aerate, and then once you shut it off, you use the basin to settle out in. So it's a very compact footprint, and overall costs come way down when you look at the difference just in tankage alone. This shows a typical two-tank SBR, and in this slide it basically represents, it's all fiberglass and stainless steel supports inside the tank and all electromechanical equipment outside the basin for ease of maintenance and long-term operation. The main advantages of an SBR is its inherent nutrient removal capabilities, and typically we will guarantee less than 10 BOD, less than 10 suspended solids, less than 3 total nitrogen, and we've guaranteed less than 1 with phosphorus with chemical addition. The whole premise of an SBR is that you're growing a specific bacteria that settles out well. You're trying to control and kill off filamentous type bacteria that tends to not want to settle, and grow a specific bacteria that will settle out quickly and basically allow you to treat to a high degree of effluent. Normal ranges are anywhere from 100,000 gallons to 15 mgd are typical flow rates for an SBR, and the SBR will usually handle very wide ranges of flows and loadings. There is no sludge recycle in the SBR, unlike a conventional system, since you're just wasting daily. And unlike a clarifier where flow still comes in while you're settling, the SBR uses the entire tank to settle out in, so there's no short circuiting. And space-wise, you can go very deep tanks, compact common wall construction, so reduce space. You have a lot of flexibility to change the set points so that you can do longer air times, longer settle times. It's really what the operator wants to adjust these variables to. And there is no space-specific tank geometry. You can basically do round, square, rectangular, any type of tank geometry. And this next slide basically shows some of those options. The top left is a square common wall construction. The top right is long, narrow, rectangular common wall construction. On the bottom left, round tanks above ground. Bottom right, round tanks partially in the ground with equipment building located between them. And really the SBR process has 5 basic steps. You fill the tank up, you aerate or react it, you allow the entire tank to settle out, and then you take your clear water off the top or decant. And then the last phase is you waste some sludge, so you're basically maintaining a bug population that doesn't get too close to your decanter. And the typical setup for an SBR is 4 6-hour cycles. So if you picture each one of these SBRs, 4 times a day we'll go through these 5 steps. And basically high flow conditions, they can speed up and do this more. Anything lower than that will stay at the 6-hour cycle, and the idle time will increase. The first phase of the process is the anaerobic or anoxic fill phase, and in this phase you're feeding the sewage into the bottom of the tank. Best settled biomass is already there, and so you're allowing them to get to the soluble BOD, and you're trying to starve off the pore settling bacteria that are up top. And so there's a pipe across the bottom that basically allows the energy to dissipate so that you get that food into the bottom of the tank without stirring the contents up. We call that manifold the flow control manifold, and it's big open slots, typically 3-inch diameter or larger, that faces the floor of the tank. So it typically runs almost the full length of the tank at 6 inches off the floor. Once you've gone through at least 50% fill period being anoxic, the air will come on, and now you're still continuing to fill to either top water level or maximum fill time, and now you're starting to aerate and mix the contents of the tank while you continue to fill. This is where you get your simultaneous nitrification, denitrification, and the bugs will start to break the waste down. Once that fill period or max fill time has been met, it will go into react, or basically just aeration. So in this case, you're typically designing so that you do a complete mix of the tank with air and mixing, and now you're just breaking that waste down. That can be done a number of ways. When you look at this slide, it's showing, typically coarse bubble up in the top left. In the middle is full floor coverage 9-inch disc. On the top right is full floor coverage tube diffusers. In the bottom left is retrievable tube diffusers. We can provide any type of aeration mixing device, and when you use a diffuser, typically for mixing you have to use either a high-speed floating mixer in the bottom center or a submersible mixer, which is mounted on the guide rail out on the outer edge of the tank, which is in the bottom right. Our preference is typically use jet aeration, and our jet aeration is called the Variox, and you can vary the amount of air to each of these jets and use basically either some type of pump, either submersible or dry pit, to recirculate the contents of the tank and compressed air to blow the air in and mix it together. The typical jet aeration header will mix at least a 50-foot wide tank, and the bottom right corner shows that right down the center. There is no electromechanical equipment out in the basin. It's all fiberglass and stainless steel, nothing to wear out or maintain or even have to get in that basin and drain it. So this is one of our main selling points, is to use jet aeration in the SBR. And you can even mix independently of the aeration. So if you have a tight nitrogen limit, you can turn the air off and drive the mixing to take the air out and cycle it back and forth. The next phases are the settle, decant, and idle. In the settle phase, there's no flow coming in, no flow going out, and you're just using the entire tank to settle out in, which is even better than a clarifier. In the decant phase, you're just trying to take the clear water off the top. And historically, everybody in the SBR markets had a different style decanter, and lots of them had issues over the years. The key is, how do you keep solids out during aeration? So you got to have a device that maintains no dirty water getting in during mixing aeration, and then when you're ready to decant, that it can take the clear water back off the top. So with that, the next slide represents our Dynacanter decanter. In this case, it's a foam-filled float on top, and the draw-off points are 18 to 24 inches below the surface. The float allows it to ride up and down with the water level, and the rubber hose that you see with the stainless steel support beams around it allow it to move up and down in the tank, not bounce against the walls. So it's same philosophy we had on everything else, is try to keep all electromechanical equipment out of the basin, ease of maintenance long term. This slide basically shows a side angle showing the effluent valve. When the control system calls for it to open, it will decant top water and stop that bottom water level through the control logic. If for some reason the operator's not there, or holiday weekends, those type of things, you have a rest at the bottom of the tank that will allow it to decant down and stop at the rest, so that you don't lose the best settled biomass at the bottom of the tank. The last phase is idle or waste sludge, and in this case we like to use a pipe with big open slots to pull from multiple points. And here you're just trying to maintain a certain sludge blanket, so you don't want that mixed liquor concentration to get so high that it starts getting sucked into your decanter. So you're always wasting some daily, and these bugs are reproducing when they eat. So you've got to maintain your bug population and waste out daily. In the bottom left-hand corner is basically showing a submersible waste sludge pump, which is what most of our competitors use, and they will typically rat hole into that and produce a very thin sludge to the digester. So it's just showing the differences. Control-wise, we have what we call a dynaphase control strategy, and SBR controls are the heart of any SBR. So you really want a good control strategy that works well for bearing flows and loadings. With this control strategy, it's constantly looking at the rise rate of the SBR and making adjustments through the programmable logic controller to adjust to those flow rates. Most of our competitors use a float and timer type control system, which is very simple but doesn't give the flexibility you need. So with the dynaphase control strategy, you always have at least one influent valve open. It does not require pre-equalization, and the cycle structure is based off the flow coming in. So there's a pressure transducer constantly looking at the rise rate and making adjustments on its own. So it's calculating the rise rate and automatically making adjustments to the process based on the flow rate up and down. The other nice feature of this is it has an initial failure response, so that if there is a major failure like an influent or effluent valve failure, it will automatically take that tank out of service and run the remaining tanks. The SBR has been used in many municipalities throughout the United States as well as industrial customers. And it's a batch process that basically treats down to a very tight effluent limit. What we're offering is to promote our experience in the marketplace and make it so that we're focused on the SBR process. We offer all types of aeration and mixing equipment in the SBR. We also have, flow control manifold for putting the waste in the bottom of the tank. We're trying to keep all electromechanical equipment out of the basin, and the dynaphase controls is the heart of the operation. Thank you for your time.